Well, hi, good morning. Thanks so much for joining me in my shop here and spending some time with me while I sort out what has happened to this radio. At the end of the last video, after doing some extensive work, the radio didn't work. Now, I'm not too surprised. Anytime I do extensive stuff, there's a good chance somewhere in there something bad went wrong. One thing that happened was I broke this coil off here, which you can't see. It's behind this protector. So this is kind of an ironic situation. So it has a cardboard protector here, I guess, to keep from whacking it and banging it. But what the cardboard protector did for me was help me forget it even exists, because I couldn't see it. As I yanked out the tuner, I yanked this coil right off I ripped it right off its form mount. But it doesn't appear to be damaged. It doesn't appear to be the cause of the problem. The cause of the problem was apparent to me when I was preparing the video, the last video which you watched. In that video, at one point, I do something I've never done before. I actually talk to myself in the future. I don't normally do this. Probably wasn't terribly apparent what I was doing. And that was the point where I was cutting off all the lead wires that come from here. And I said, okay, so the black one goes here, and the red one goes here, and the blue one goes here. And at the moment that came out of that video, I went, blue one? What blue one? I put a red one there. Where's the blue one? Well, the blue wire never made it. That's probably why the radio didn't work. The blue wire is still up here. So I'm going to fix that now. I'm going to pull the blue wire down, hook it up, correct the red wire. I'm going to plug this guy in. And at that point, I'm pretty hopeful it's going to work. Because, you only make one mistake when you do something wrong like that. You never make two or three. Okay, so I'm going to fix that wire. And I'm going to give it another try. Okay, ready now for another attempt at running this radio. The unfortunate fact is, the mistake I made in wiring it wasn't so much leaving a wire off. I put a wire in the wrong spot. Putting a wire in the wrong spot can cause who knows what kind of consequences could have happened. There's a chance I popped some of those very sensitive tubes in there, unfortunately, and we're going to find out now. Is there another mistake in here? Could be. Did I just make another mistake? I don't think so, but could be. So I'm looking at the dim bulb here, and the set is off. Okay, flip it on, and first I'm going to cross my fingers. AM band. Oh yeah, this thing again. So this went south, completely south. I didn't even talk about the mistakes I made with this. You didn't see it on video because I cut it out because it was just not worth watching. But what I did here was, when I put the string back on, it was really, really loose. And rather than realizing, for crying out loud, I hadn't run the string through this pulley, which I now realize, I eventually concluded the spring had been stretched somehow in my monkeying, and that I had to shorten the spring and therefore shorten the string tighter. So I did that. Now the string is nice and tight, but it doesn't go through here, and worse yet, it's come loose down here. Everything's gone south. So I got this all wrong. So how do we know for sure this is on the right band? Only by manually doing it. Shut the power, cut the power, cut the power. Only by doing it by hand. Okay, I think this. Okay, that's the AM band. Hopefully we don't have to do that forever. Every time you want to change bands, you gotta take the radio out and lift the chassis. Okay, once again, switch off, power available. Come on, little radio, do your thing. Okay. Yeah, we don't exactly want to hear that sound, but that's okay. Oh boy. That really sounds like something coming out of this radio itself. Don't think that's being received. capacitor is closed, somehow the pointer is off. I didn't do anything to this string. Oh my gosh. Is it really just this radio? Let's listen to another radio in here. Let's see. Well, okay, so that sound can be coming from this radio. It can be oscillations in AVC circuit. Let's push some of these buttons here. Different band. Yeah, I'm going to reach up under there and turn the band. Yeah. Okay, that's really thoroughly disappointing now. Yeah, thoroughly disappointing. Okay, so I'm going to give the radio another chance. I changed it to another band. I think I've got it on the 31 meter band, but I'm not absolutely sure. This mark doesn't mean anything anymore. So I have an outdoor antenna hooked up to it, and we're going to see what happens. The last band was the broadcast band, so we're going to give this guy a chance. Turn it down. Here he goes. Sounds good actually, but so I could be on this band or it could be on this one. Pretty sure though I'm on the 9. The 9 should be alive. There should be stuff there. And something's happened here. Loose antenna. Aha! Ooh, a thumbs up. Whew. Thank God for that, because, man. Sounds like no AVC action. The radio static didn't seem to come up as I tuned off the station. Let's go back to it. What the heck was that? The difference in the strength between the two stations here, this one and this one, and in between, it's pretty silent. I think the AVC is not AVCing. That's what I think. But not bad. Sing for joy. Okay, that's great. So what's going on the AM band, I'm not absolutely sure. What to do next, I'm not absolutely sure either. I'm going to think a little bit about it and figure out the next step. I think it's back to alignment myself. So here's something on the schematic I hadn't really noticed before. When I was just studying the way in which the speaker's handled to see if there was a ground wire or something coming from the speaker back to the chassis or something like that. Just trying to be safe in how I hook up my equipment to the speaker. And I noticed this winding. I hadn't really noticed it before. And it comes down And it gets involved in all these tone control switches. See how it's here, it's switched past this resistor or through the resistor, through the capacitor, passing the resistor, or through the resistor, depending upon how you flip these switches, these tone control switches. Now you can see the output from this little circuit here travels on this wire, and it says right on it, feedback. And up it goes into the bottom of the volume control. So I think, you know, this is really clarifying something for me. This resistor out here. So I think radio manufacturers manufacturing these controls, these potentiometers, realized that this is what was going on in a lot of radios, and so they incorporated this right into the volume control in the form of what I call a back tab, or a fourth tab, usually sticking out kind of the hind side of the volume control. And maybe that's always a point where feedback is being pushed in. So here they had to imitate it by putting an extra resistor here, kind of lifting the volume control a little bit off ground. So all the tone control is done by fiddling around with phasing and things like that with the feedback. That'd be my understanding of this. Maybe if you feedback more treble, maybe you cut the treble coming out, and if you feedback more bass, maybe you cut the bass coming out in the speaker. I'm not exactly sure, but I thought that was kind of interesting how they did it. That's not, well, for me this isn't common. I'm used to just the usual drag the treble down and throw it away type tone control. Maybe this has some bearing on distortion improvement or something, doing tone this way. And the whole purpose of the feedback line is to basically, it's a type of error correction in which the errors coming out towards the speaker are reversed and shot back into the amplifier to counter the error. And it sounds kind of impossible, but that's how it actually works. You know, this is an analog circuit. Everything is happening at once. I guess that's the best way to put it. Anyway, I thought that was interesting. I hadn't really realized that. Good enough. Enough talk. Okay, quick review of the alignment instructions. Here's the removing the turret. Oh, yikes, yikes, get out. Had enough of that. Got some ways to connect your signal generator to the radio when the time comes. Dummy antenna for bands 1 and 5. Dummy antenna for 2, 3, 4, but not 5 and 6. Okay, that's not quite what we need to do now. Okay, alignment instructions. Let's just whip through these quickly. Be sure set and signal generator are thoroughly warmed up. Use accurate signal generator. Set volume control to maximum. Raise front cover on the TW2000 to place loop in its antenna. That's not mine. Mine's a 2000. That doesn't matter. Connect output meter across speaker voice coil. I decided to do that this time. To avoid AVC action, use lowest output. The local oscillator frequency is, this is important here. Local oscillator frequency is higher than the signal frequency on these bands. The local oscillator is lower than the signal frequency on all other bands. So this may become a critical factor as we work our way through that part, but I'm just aiming for the IF right now, just to align the IF transformers. To adjust oscillator slugs, it will be necessary to first remove the baffle board. Hey, I already did that. And dial assemblies. Huh? Removing tuner. Necessary to first remove the baffle board. Just the baffle board. Oh, that's right. You can't get the baffle board because it's interfered with that front dial plate. But you can loosen the dial plate and sneak the board out. You don't have to remove the dial plate. That's what I discovered. Some sets have removable button plug. Now this would be smart for me to drill a hole and put a plug in it right on the front on that baffle board, so you can get at that oscillator slug without doing all this work. The RF and antenna slugs are accessible through the opening at the rear of the tuner. Note, it is necessary to unclip and remove the antenna coil strip of the band being aligned to gain access to the RF slug. You see what they're saying here? I'll show you on the radio what they're saying here. Refer to 4 and 7 for location of alignment adjustment. Alignment adjustment shown in a schematic diagram. Great. Okay. Signal generator connection high side through a 0.1 microfarad capacitor to the stator plates of the center section. I've done that. That's how my signal generator is connected. We'll set it to 455. Oh, band selector setting 7. Okay, so I think which one is 7? Oh my gosh, which band is 7? Did they number them on the front? They did. So band 7 is the broadcast band, and then we do this. Set at 1,000. That's roughly mid band, isn't it? Okay, let's carry on here. That's all other stuff. So I've arranged the screen so you can still see the alignment instructions, and you can see the big meter here, which doesn't appear to be working, does it? Is it on? Oh yeah, it's on. I have a lot of trouble with this meter, but we'll see how it goes. Just to give you the shop view of things. Oh, camera in the way. Now, signal generator output has to connect to the capacitor here and to the chassis. I'm going to use this spot right here. Okay, that's the signal generator. Got the tool for adjusting stuff. I think we're all set to go here. Just check the power cable, make sure it's okay. Yep. And then I've got to get this tool in. Oh, what was that? What was that? Oh, just caught on here. Okay. We're down in here. Now, the last time I tried aligning this, I did a lot of video stuff I did not put on the internet. So you didn't see this, but look at how much play there is. The slot in the top of these slugs is a great big wide thing. A little less play on the plastic side, but crazy. A small enough screwdriver. I tried this first with a small bladed screwdriver, and it actually rotated around within the slot. And that just confused the heck out of me. So, journeys taken off camera before, or actually on camera but never posted. I think we're ready now. I think we're ready. Okay, so I'll switch on the radio. Volume's critical this time. Here we go. Power on. Switch on. What was that? Well, that was some horrifying thing. Oh, that was something horrible. Well, let's keep going here. Signal generator is set high output, and it's at 464. Oh yeah, let's tune it and see what happens here. Oh, come on, there we are. Okay, a little more power. So all these, look at all these things here. Just tune up from here. 1, 2, 3, 4, 5, 6, 7. Oh, what was it? So look at that. So we still got lots of problems here. Oh my gosh. Wow. Wow, wow, wow. I was not expecting that. What I'm expecting is just one tone at 455 and not all this other stuff, especially this thing here. Where? That guy. That's the messiest thing I've ever heard coming out of a radio. So I could be overdriving the input. I got my signal generator going full tilt, basically. It shouldn't require that, I wouldn't think. So let's see if we can back it down. The volume's already on full. Okay, we'll tune it in, and then we'll back it down to the lowest possible power. So that's still quite a strong signal. Not much left of it though. Now those other effects are still there, we just can't hear them anymore. I'm not sure that's solving anything. Now the main peak shows up quite clearly. Let's go after that. So my signal generator needs to be set about here to be 455. There's a little error in my digital meter there. Now, good luck on getting this to show up on here. This is already set quite sensitive. I mean, I can't hear anything coming out of the speaker. How am I gonna? Well, there's a hum there. Just trying to fix the lighting a little bit here in the shop. Not doing too good. Meter jumping around, I'm not even hearing any of that. Now there's a few clicks and pops in there. What to do, what to do. We'll give it a little more from the signal generator. Get the tone up onto that voltmeter. And for all I know, when I align this, all this funny business will go away. So now, I have to ask myself, is that the radio or is that my meter doing that jumping around? No, it's definitely coming from the radio. Okay, I'm going to make an attempt at aligning this guy. This is meant to do the second IF. Pretty broad. Okay, and from underneath. This isn't going well at all. It's not getting, I can hear it, but I can't see it on the meter properly. Go back to ABC, give it a little more power on the signal generator here. Now there's a nice clear tone coming out of the speaker. The noise has disappeared. Just make this meter more sensitive here. Okay. Now I'm going to turn the volume, make sure that meter's following it. Perfect. Okay, now we're cooking with gas. Let's try this alignment thing again. Hey, who's ringing? Uh-oh. Uh-oh. Uh-oh, uh-oh, uh-oh. What exactly happened there? Tap the shell on this tube. Is the tube out inside? Once you put the shell on, you can't actually see it. This is not good. It's not good because you don't want the tube heater to become disconnected in this radio. Threatens everything. How's that look now? Okay, I think we're cooking with even more gas now. So that's some noise thing. Let's get rid of that. Good. Okay. Hanging around too. Let's try again. How would you ever know if you turn this radio on if you know, tubes are in contact properly? And okay, we're still at 453 or 455 rather. Okay, on that, what's next on the hit parade here? So we do the other two. Oh, we do them all without moving the signal generator. Okay. Let's try that. I don't like the sound of that static we just heard. Okay, wait, hold still. Hard time turning this smoothly. Okay, peak seems to be there. Underneath, I did work at aligning this radio earlier. There's that static again. I don't like that static. I don't like the sound of that. Yuck. Makes it. There. There we go. Back to the first, second, whatever it was. And the bottom. Pretty clear. So this time the IF is working the way the IF should. Not, oh my gosh, listen to that. So I don't know if that's coming across on the microphone or not, but there was a ring in there that persisted. I say. It's just this one tube's very noisy. There it is, IF aligned. I'm trying to identify where the static is coming from. I do not like the sound of that. Okay, let's try the AM band again. Oh boy. So that sound can be lots of different things. It can be a capacitor breaking down. It can be a resistor. a carbon resistor. But that kind of sharp clicky sound, from my experience, usually tracks back to a tube doing that. Pretty hard to sort that out. Boy, oh boy, oh boy, oh boy. Well, we think we're on band 7. We're on the AM band. Let's see what we can pick up here. I'll remove this. Let me turn the volume down first. Remove that. So we're on the loop antenna here. The stick antenna, loop, whatever it's called. Oh my gosh. I'm not on the band I think I'm on. Power off. It's got my finger. It's got me. You know what? I turned the radio around the other way. So this is the way to push it. I believe that is band number 7, the AM band. Just a second here. Think about it, man. This is all the way this way. Yep, I think that's right. I think that's the AM band. Let's put the radio back on. Okay, I hear a little bit of static. This is still one sick radio. Well, I've left the radio running for quite a while here now. Let's try something I haven't done yet. Do a heat run test on it. Is that this? Don't think so. Wow, what was that? That was another failure indication, I think. Some component is failing in here. What's hot? Okay, so I have a lot of trouble showing this on camera. Alright, let me just change the setting, raise the red. Quite clearly this guy's warm. And this one. These are the two large resistors. Anybody else? Okay, so what we're going to try... No, the answer is no. Nobody else is hot. No heat problems in here. We will try the signal tracer and see if we can find out where this popping is really loud. I'm quite worried about this package thing here. Signal tracer. Signal tracer ground. This might make a pop. Tracer set to audio. Volume down on the radio. We're going to start right at the volume control. And you're going to have to try to identify which is the radio and which is my tracer. I'm going to have my hand on the volume control, the signal tracer. So output of the volume control is right here. Hear any yeah, turn it right off. If I turn it down, of course, what am I doing? I'm reducing the signal I'm testing. So let me go on the input side. Oh, sorry. Yeah, feedback there. Now we've got here unsoldered capacitor. Son of a gun. Really? Unsoldered capacitor. Hey, that's a great tool. Signal tracer. Find your bad soldering jobs. Oh my gosh, I can't believe it. It looks like a bad job anyway. Well, it doesn't look like a bad job. It looks like a job forgotten is what it looks like. Let me get a hold of it. Usually I'm pretty careful at testing all this stuff afterwards. No, it's not soldered. Oh my gosh. What a bozo. Well, and I don't know how much effect that might have, but we will see. It might have a lot. It might have a lot. But you know, I banged the receiver to see if the static was related to something like this, and it didn't respond. So I still think it's an internal component issue. Sets off, power's off. I have a feeling I'm on my way to a long, long troubleshooting period here. Okay, he's soldered now. Now that's one of the tone control capacitors. It probably had... Oh, I was going to say it probably had no bearing on anything, but let's give it another go. Here we go. Volume up. Yeah. We'll start right back there again. We're starting at the input to the volume control. Other than a hum, it's just maybe I didn't get the input. So I didn't hear the clicking on the input to the volume control. So now we're going to go to, oh boy, where? We'll poke around at these different capacitors here. Here, there. That's the input. That's the input to the volume control. So we hear it there. We hear it there. And then from that, we go all the way to here. getting louder, getting more distinct as I move towards down in here. Ow! Sorry. Get my hand on the volume. Where'd it go? Where'd the clicking go? Don't stop on me now. Here it comes. Interesting in itself, listening to all these. Hear a little bit there. So there's 4 terminals on that transformer. 3 of them sounded quiet. Let's try that again. Okay. Starting with the clicky one. Clicky there, feedback. Clicky, clicky on all. Okay, who's got the loudest clicky? So without changing the volume control now. Oh, listen to that. What the heck just happened here? I think my wife just Bluetoothed a bit of music into my shop here by accident. Music, some guy talking. So that voice, if you heard it, so it's all around here. Let's try all these now. Okay, hand on the volume. Oh my gosh, it changed. It changed. It sounds the snappiest on this one. Man, live. So this is a resistor I installed in these 2 capacitors. Are they somehow in on this deal? Shouldn't hear anything there. That's ground. Nothing sounds as alive as this. So that tracks back to this tube. Multiple scares there. Put the solder away before I have an accident with it. Well, okay, so we've got the tube here and the transformer here, and the sound is gone now. So how to deal with this, especially when the sound is gone? This tube, You know, I have to do, I have to replace this tube with another tube, see if the click goes away. In this radio, you can't pull the tube out and see what happens because bad things will have happened instantly. You can't do that in this radio. Most of the clicking is gone. Not that this should do anything, but I'm going to put some pressure on the slug here. And I'm going to wiggle the can a little bit if I can. If I can do it. No, it's all the kind of sound that's internal to a component. Cool spray would be good, but I don't have any anymore. I used it all up. And now it's gone quiet again. These are all really bad signs. It's possible that doing all the capacitors has raised the B plus a little bit in this radio, enough to make this problem become apparent. I can't say I noticed it before, and now it's gone again. In the meantime, how well is this radio working? Let me take this ground off here. In the meantime, okay, let me turn off my tracer so we're not hearing that. Other than the click, has a nice mellow sort of hiss to it. It's not really what we're looking for in a radio, though. Buy this radio, has a really nice hiss. I heard a station there and I ignored it. This is full blast too. That's an indication of something not so good. You have to have the radio turned up full even to hear the pleasant hiss. Yeah, that loop antenna has problems, doesn't it? Is that what's going on here? Ooh. You know what it is? Only I don't know which way is the good way. I have another antenna to try. Where's that other antenna? Let's just put on the external antenna. Let's do that. External antenna. Oh, hey, what's that? Something changed there when I did that. Okay. The almighty stick. Jeez, stepped on the camera wire there. What's going on right down in here? Wow. Somebody's not happy here. Well, something going on right there. So the most sensitive spot is where that looks like a really. So I wrap the wire around the terminal and then solder it. Sometimes a lot of the wire is left unsoldered. Sure, it looks all soldered up solid, but what I gotta do is looking very closely to see if there's a short in there or something. It sets off, so I'm moving this stuff. I could be correcting something. No, I don't see anything wrong in here. Let's hit it with some solder. Very odd. All that oscillation, that sounds very much like a mechanical ringing coming from, I don't know, a cold solder joint like this, if this is what this is. Did talk about lead dress, didn't it? I mean, this is a dramatic change from what was in here. But okay, well, let's give it another go here. becoming a musical instrument. Oh boy, I think I know what the problem is here. I don't think I need to test it anymore. So the sharpest static sound came when touching this terminal on this IF transformer. Some IF transformers have capacitors that are inherent inside the actual structure of the form of the coil inside the can. And sometimes those capacitors develop a condition commonly known as Silver Mica Disease. Silver Mica Disease, when you hear it, it sounds like lightning crashes. That's pretty much what this sounds like, isn't it? And the sound is bound to be strongest when you get closest to where the crashes are coming from. It'll be right on the terminal of one of these two IFs. It poked all over the place. Don't know what that funny ringing thing is. I don't really know what was going on up in here. But aside from that, that powerful clicking, popping, all of it suggests a defect in that IF, which is another whole world of pain to try to correct. It can be done, but first thing I need to do, I'm not going to do it today, first thing I need to do is this really the type that has the capacitors inherent in it? And you know, boy, it'd be, yeah, I'm pretty sure it is. Let's just take a look on the schematic here and see what that tells us. So if we look at the IF cans, you see how the capacitors are shown inside the can. So the only way forward for me at this point is to assume that this is what has happened. It's Silver Mica Disease in well, one of these two cans. Which one? I'm not sure which one it is. One of these two. And to fix it, I have to extract the transformer and manipulate, really destroy these capacitors and then replace them. The challenge in doing that is, you see, they didn't write the capacitance here. So how much capacitance do you put in there? 1 picofarad, 10 picofarads, 50 picofarads? That's the challenge. It's really not a place I wanted to go, but you know, what can you do? There's no way around this. If this is the problem, if this is Silver Mica Disease, it has to be dealt with directly. You can't get around it. Proving that it's Silver Mica Disease, kind of at this point, I think we got to make an examination of the transformer. You know what? I might be able to get the cans off with the transformers in place. Let me just take a look and see if that's possible. Probably is possible. I'm not sure. I think if I pry up on that clip. Yeah, that's the whole transformer will come loose here, but that's okay. The wires will hold it. The question is, will this can come off? Come off. Leave it behind. Well, I'm 1 inch from just removing the whole thing. I'm closer than 1 inch. Now, how long are these little wires here? Can I extend that over? Red one I certainly can. This blue one, I have to replace it. These two guys, well, I put them in. Just gonna nip them off. Replace them all later if I have to. Up here's a green wire, lots of extra wire. These can all go back on. And we have to replace that resistor. Out you come. Okay, let's just change things a little bit here. There we go. I'm going to bring over the close-up camera too. So I really want to take a good close look at this guy. Change the focus here. Not too much to see in this area, but I do see our color coding. This was in the green dot anyways. This is the main color code. Now popping this guy out. Doesn't he just fall out at this point? Oh. Bent tabs. I'm not trying to cut these, I'm just trying to do that. Okay. Out with the transformer. And we'll look at those silver mica capacitors down the bottom here. Where exactly? looking right at it. It's incorporated right in this plastic here. There's a metal sheet right here. Trying to see through the plastic. Wow. So here you can see from this terminal up through, and there's a piece of metal bent over coming into this area. That's the kind of thing I have to nip that away. I have to nip away that little metal band. I would disconnect the capacitor. On this side, the same sort of thing happening there. You see the coil wires, how close they are. So that center rivet is also implicated in this. We could get rid of the, I think, we can get rid of this rivet, and the whole thing will just fall apart at that point, won't it? So that rivet is what's holding together the two plastic pieces, and sandwiched between them is the capacitor, and its dielectric is in there too. Is this for sure a problem? This guy? Is there some way we can prove it now when he's out here like this? Two capacitors built into this. So I do see some black staining and stuff, but I don't know if that's... I have seen silver mica under the microscope and under this kind of magnification. It's quite apparent. So if you look just beyond the end of my thumb there, you can see some black streaking. I don't know what to make of that. See black all around the edges too. Silver is non-metallic silver, a silver salt of some sort. Usually they're black. So I'm looking for the easy way out of this situation. So now I can see quite clearly the rivet is holding a metal clip, and the clip is pushing on the metal tab that comes out the end here and heads down to this terminal. That tab is being pushed down onto something, and then underneath it, can't see through it. What would be the connection to it would have to be here. See, there is another tab, and I think it's covered by mica or something right in here, right where my thumbnail is, right there. So it disappears underneath. So this white material here is the dielectric, and this is one plate, the silver here, silvery color, and the other plate is just hidden under it here. So destroying this capacitor is critical. It's constructed the same way. It all looks the same. I see lots of black stuff now that I look at it, all around the borders there. How can we prove this guy has silver mica disease? Put voltage on him? No, I think I'd be going crazy trying to do that. It's out of the radio, it's in my hand, so I have to figure out how to disable the capacitors in here. Occasionally the tab comes down, it's a separate tab coming down here. But it's not, it's just one piece of metal, terminal metal. Just brought it up and then bent it over and then clamped it down and riveted it. Can you see the machine parts just flying while they're making this thing? Next one. Just pump them out, one after another. Wow. So, what if I just cut the band there? If I were to somehow cut that band right up here by my thumbnail, just cut it there, and then the capacitor is disabled. And then I fit in some new capacitors down here, real ones. Of some value, of some unknown value. Can you see it? My hands have gotten sweaty. I'm sweating. I'm looking at this and I'm sweating because so there's the huge slot that my screwdriver was not working well in. My little screwdriver. That's a whopper of a slot. You know what it is? It's a gigantic slug. I'm picturing a little tiny slug with a little tiny slot. But a big slug deserves a big slot. What's now this retaining clip here? What happens if I yank that out? What's that doing? Is there another set of capacitors up in there? I don't think so. Or a capacitor. Typically they're in the base. Some green stuff on some of the wires there, but I don't think it's corrosion. Yeah. Oh boy. I'm just waiting for the great idea to jump into my head. Okay, just looked at this long enough. It's not getting any better. I'm going to go now and ponder the situation for a while. Decide what the smart move is. What is the smart move? Oh, that didn't sound like a smart move. Okay, thanks a lot for watching, and we're just going to keep plodding ahead here.